All right, good evening, everyone. So today we are going to be going over more stuff with quadratic graphs. So today is the second out of 3 lessons. We're going to have one more on quadratics, and then we're going to be all done. But today's lesson is going to focus on something called end behavior. We haven't actually really looked at that many quadratic graphs, and again, we're at home. We're not really going to be doing a whole lot of this. If we were at school, maybe we would be doing a deeper dive into this subject, but we're going to kind of just skim the surface, do really basic stuff. So we're going to see what a quadratic graph looks like right now. You can use this resource yourself. So if you want to just look at see what they look like, desmos.com/calculator. It's a really easy online graphing calculator. Some of you might own a graphing calculator. This one looks pretty nice and is cheap, i.e. free. It's online. It's a great resource. I use it all the time. So y equals x squared. Quadratic just means that there's an x squared in it. It's the highest term, but that's the highest degree of the function. So in this function, we can see how this has a curve, and this is what a quadratic equation is supposed to look like. You're supposed to have a curve that goes down and goes back up. So this is a quadratic equation. We can change this by adding things like plus 3x minus 5 plus, let me change it to like plus 2. I don't know. So you can remember, if you remember in your tables, the numbers would go down and then they would go back up. Well, you can see that here, these numbers, they go down, they reach a certain point. It's a decimal, whatever. And then they go back up again. What we're going to focus on today is something called end behavior. So kind of sounds complicated, but all it really means is that this graph is going up. So you can see how it curves down and then goes back up and reaches some point, bottom point like that. We're also going to talk about graphs that go the opposite way. So I can change this a little bit. And let's say we have negative 1x to the 21 squared. So see how this graph, it's the same kind of idea. We have a squared still, but this graph goes down, and it's a really, really simple way to get that. So we are going to talk about something called the leading coefficient. So end behavior has to do with the directions the ends of the graph go. So whether the ends of my graph are going up or if they're going down. And to determine end behavior, all you have to do is look at the leading coefficient. So, and we're going to define that. The leading coefficient is the first coefficient. Coefficient means number being multiplied by a variable in the equation. So when we look at this in an equation like y equals ax squared plus bx plus c, that refers to the a in the ax squared. So it's the number in the very front. So if we were to use an example, let's say that we had 2x squared plus 3x minus 5. Get rid of that thing. There we go. The leading coefficient here would be that 2. That 2 right there. So that's the leading coefficient because that's the number that's in front. It's leading, it's in front. So if this number is positive, we could change that to a 3, 4, 1, whatever. You notice how this graph is always going up. We always have the ends go upwards. So that means that if the leading coefficient is positive, and then the way that we write this out is the graph opens up. Opens up means the points go up. And it looks like this. So the graph opens up. And then, of course, the opposite is true. So if I were to change this, let's write out a different equation. So let's say we had y equals negative 1x squared, not 21, keep on hitting that, plus 3x minus 1, whatever, minus 2, so our numbers are different. That would mean that the negative 1 is the leading coefficient, If you have a leading coefficient that is negative, you can see how in this example our graph is going down because the two ends kind of go. It's not a V, but the U is pointing downwards. So since that number is negative, we have a graph that opens down. And you could change that to any other negative number. So like -3 goes down really quickly in this case. You could change that to a -8, goes down really quickly if you make it bigger. But in all of these cases, the graph is opening down. It's the vocab term that we're going to use. So let's go back to this. And we'll say that this opens. There we go. So if the leading coefficient is negative, you get something that looks like this, can move around, can get skinnier, fatter, whatever, and the graph opens down. So we can have other examples of this. For instance, y equals -3x squared plus 5x minus 2. Doesn't really, I don't really care what these other numbers are, so long as that number right there is negative. An example of this would be y equals, let's do something silly, equals 42x squared plus 5x minus 8. Doesn't matter that there's a negative number in here. That number 42, that's positive, so that opens up. So for today's lesson, all you need to remember is I can ignore the rest of my graph. If this number in the front is positive, our graph will open up. It will look like a smiley face, and it will open up like that. And if the leading coefficient is negative, like in this example, the -3, that means the graph opens down and the points are going to go down like that. So, if you have any questions on that, pretty simple concept, but if you have any questions, please let me know. Please come in and say hi and maybe send me an email if you're still confused. And good luck on the homework, guys. Have a great day.